We think it's an integral part to a tractor, and any tractor that doesn't have it isn't worth owning and operating daily. I'm Aaron Graber with Ventrac, and in this video, we're going to talk all about oscillation. Everyone knows our tractor articulates to turn, but the frame also oscillates, and that makes it respond to the terrain very differently from your typical compact tractor. Most machines will have a straight frame, and then they'll have front axles that are either rigid or suspended from the frame. The machine then has to rely on that suspension to contour to the ground, and it never works very well. The Ventrac does this very differently. The center of our machine pivots in 2 dimensions, so it articulates to turn and it also oscillates to hug the terrain. What that does is it keeps consistent ground pressure on all 4 corners of the tractor at all times. This improves traction, stability, and maneuverability no matter what terrain you're working on. Imagine you're driving along on a perfectly flat surface and you encounter a hole. The hole is only big enough to drop 1 corner of the tractor in. On a typical compact tractor, if that front left wheel drops in the hole, then it's going to pull the whole machine down into that hole, and your right rear tire is going to want to come off the ground. On a Ventrac, it responds very differently. The front left tire will also drop into the hole, but because the frame itself oscillates, only the front half of the frame will do that, leaving the back half of the frame and the rear right tire firmly on the ground. You'll still have all 4 points of contact with very consistent ground pressure, where on the traditional tractor, you might only have 3 points of contact, or if you do still have all 4 tires on the ground, the right rear will be very, very light and you'll break traction. For the operator on the traditional compact tractor, this will create an unstable work environment and it'll be very difficult to navigate past that obstacle. The Ventrac operator will barely feel it as they crawl over that hole with no problems. To demonstrate this principle, we have a ramp here that we're going to drive up. Our tractor has the ability to raise 1 wheel, the inside wheel of the machine, up to 8 inches off the ground before any of the other 3 wheels leave the ground themselves. So we're going to drive up this ramp, and what that's going to do is twist the front end of the tractor, and it's going to oscillate at that center joint to show driving up an obstruction, or it would be also like simulating dropping the right side of the machine into a hole. And because we're going to be using a prop that we built ourselves, which is this ramp, we're going to do an installment of absurd things we do at Ventrac. So here it is, Exhibit A. You know those truck ramps or car ramps that you can get at any automotive store? They're like formed plastic, they have some structure underneath, so they're pretty strong. They'll hold basically a 1-ton pickup truck and they cost 40 bucks. Well, we could have bought those, but instead we made our own because why get something that can support a pickup truck when you can build your own and it'll support a semi? This ramp is like 60 pounds. You can't even carry it. We had to use anti-scalp wheels on the front, as you can see, so that you can easily roll it around. This is what you find here. We say we have a problem to solve, and there might be a solution to it that is cheaper, but maybe a little bit less desirable, and we say we can do that better. So anyway, back to the video. I'm gonna drive the tractor on top of this indestructible ramp and show you what oscillation looks like in the real world. Okay, so as you can see, this corner of the tractor is off the ground, and all 3 of the other corners of the tractor are still on the ground. The whole point is the front half of the machine is twisted while the back of the machine is squarely on the ground like it would have been if we were only on a flat surface. What this does is it keeps near perfect traction on every corner. So I can drive up and over an obstacle or drop a corner down into a hole and still have traction on the entire machine. I also don't upset the dynamics of whatever's happening in the operator station. When you combine the fact that we are also working with the front attachment in float, then the attachment itself is also traversing this area all on its own. It's doing its own thing, it's dealing with this area of the terrain before the tractor even gets there, so the attachment isn't pulling or pushing the tractor in one direction either. You can kind of think about the whole setup as like a caterpillar. It's crawling up and over and around things so that the stability of the machine isn't disrupted while all of the individual parts interact with one specific area of the terrain by themselves. We often get asked about locking differentials, which we don't have on our machine. And a lot of people wonder how we can actually drive over terrain that's difficult without locking differentials, because wouldn't we just put a tire in the air and then totally break traction and lose drive? Well, no, because since we don't have tires in the air and we oscillate to contour to the ground, we don't need locking differentials. And because we don't have a locking differential, the operator isn't in charge of flipping that back and forth. And since we have full-time open differentials and the operator isn't choosing between one or the other, the tractor is much more delicate on the turf that it's working on. You don't have to worry about tearing the turf as you're making a turn because the differentials are always full-time open. We also get a lot of comments from operators that use our machines that they're very comfortable. Typically it's in the form of something like, hey, what kind of seat are you using? This is one of the most comfortable machines I've ever driven. And even though we have a really great seat, it doesn't come down to the seat at all. The seat's actually mounted on a rigid seat pan, or we have a suspension seat option, but it's also mounted on a rigid pan. Most of that comfort comes in the fact that the frame itself is contouring to the terrain underneath of you, and you're not actually feeling the bumps underneath of you. It's not that the tractor is inherently better at smoothing out bumps that exist, it's that the tractor doesn't necessarily even feel that they're there. Other machines are tasked with hitting a bump in the terrain and then finding some way to dampen the operator from that. What this means is you drive over a bump and the force from that is translated directly to the operator. So you'll see all kinds of tricks to minimize that. You'll see suspension, you'll see suspension seats, you'll see all kinds of different linkages and tricks to try and minimize that impact to the operator and keep the operator from feeling it. We do the same thing with our seat, but we also don't have the same problem to solve. It's a much smaller issue because our machine interacts with the terrain differently. Another thing I want to talk about is the center of gravity of our machine. Since we are very focused on operating on slopes and hilly terrain, center of gravity matters a lot. We're already a low platform with very low ground pressure, but what that also means is that any upsetting the machine could be a negative effect. And so we minimize that using the oscillation in the frame. What I mean by that is if you imagine I'm driving along a slope, let's say it's angled this direction, as indicated by the front of the tractor, and I drop the front right tire into a bit of a hole. Say it's a groundhog hole or something. What would happen if I was on a regular tractor, totally straight frame, is that the back left of the machine would want to pull up. And what that does is it upsets the stance of the machine, raises your center of gravity, and gives it more of a chance to have problems traversing over that hill. But as you can see, even with my front right dropped into a figurative hole, the back of my machine hasn't changed at all. So I haven't raised the back left and I haven't upset the machine at all, which means I'm still just as capable driving along that slope as I was before I hit that hole. So almost everywhere that you operate is not going to be a smooth glass-like surface. And even a 1 or 2 inch change in elevation that is experienced by one corner of your machine can cause a very distinct change in ground pressure that is exhibited onto the terrain. And if you're in a very delicate area, you'll notice that in the form of damage to the terrain. If you think about operating on a golf course especially, where the grass is very short and the standards are very high, if you have a massive change in the ground pressure of your machine, you're likely to leave ruts or indentations. Since we have the flex frame and the oscillation, we maintain as consistent ground pressure as possible on all 4 corners of the machine, which means that the lightness of the machine is preserved. We're not concentrating the ground pressure and the ground force in one area like straight frame machines might be, and we're much less likely to leave ruts or indentations in very delicate areas of the terrain. This comes in handy even on traditional turf areas like on soccer fields, football fields, or even in your average lawn that is pretty flat, but when the ground is wet or the terrain is soft, is susceptible to leaving ruts no matter what machine you're operating. To expand on that point, we often get the question, what is the specific ground pressure of our machine? And we don't answer it specifically for a couple key reasons. We could measure it in a lab, and it would be somewhere in that mid to low single digit range, which is very impressive and comparable to some wide tracked machines. But the key difference is that we maintain our ground pressure more consistently and more regularly than any of those machines. And the reason is down to the oscillation and the flex frame. Even if we measure 1 or 2 psi higher than the lowest ground pressure machine that exists, the moment that machine interacts one change in the terrain, then most of the weight of that machine is concentrated in a very small area, and their ground pressure spikes to orders of magnitude higher than what ours is. So you'll often hear operators talk about what seems like a magic ability of the Ventrac to drive over areas and either not get stuck or not destroy the area underneath of it, and that's because of that consistently low ground pressure that we can maintain. The advantages of the FlexFrame and the oscillation that we've been talking about also extend to the versatility of Ventrac. Obviously, it's important to have these features built into the machine for delicate mowing, like you would be doing on a golf course. But when you use the same machine to do other jobs that are more invasive, the results are even more dramatic. If I take a Ventrac with a trencher and I go dig a trench through a backyard, and let's say it's a spring day with soft turf conditions, I'm gonna do almost no damage to the grass around me. So even though I have a trench dug that needs backfilled, everything else around it looks like I wasn't even there. And that's where you get contractors and property owners where those contractors are working praising the Ventrac for how invasive it's not. When the job is done, it looks like the machine was never even back there, and there's not as much work to fix at the end of your jobs. There you have it. That's oscillation on a Ventrac 4520. It's a feature that we have built in that a lot of people don't really recognize right away or don't appreciate to its fullest extent. And it's not something that we do better than other people. It's something that we do. Most people don't do it at all. So if you're looking for a tractor that has the ability to do these things and provide that magic finish, the Ventrac is really your only option. Here at Ventrac, we believe in the FlexFrame completely. We think it's an integral part to a tractor, and any tractor that doesn't have it isn't worth owning and operating daily. If that makes sense to you, you can see more information on this machine at ventrac.com. You can check out all of the different attachments and different options, and then you can follow us right here on YouTube for more videos that showcase the Ventrac 4520 and the FlexFrame that underpins it. Thanks for watching.